Hey guys, welcome to this video on 8.1, solving equations using addition or subtraction. In the last video, we learned how to solve equations using substitution. While substitution can be a good method for some problems, it doesn't work quite as easily for other problems. Later on, when you guys are in pre-algebra and algebra 1, you are going to be solving problems like this. Yes, they are going to be that long. Would you want to use substitution to solve this problem? Probably not. It would take you a long time to find the right number to substitute into every single one of these x's to make the equation true. Substitution is not going to be a good method to solve this type of problem. So really, when you're doing problems in pre-algebra and algebra 1, you're not really going to use the substitution method. Instead, you're going to use a method called isolating the variable. We're not going to work on problems quite this big this year. However, the method that we start to learn in this video is very, very, very important, because if you start to get practice with this method now, then it's going to be easier later when you do move into more difficult problems. Today, the types of problems that we're going to be solving are just going to look like this. Now, I know that that type of problem can also easily be solved by using the substitution method. However, we are not going to use the substitution method today. Instead, we're going to practice the method of isolating the variable in order to get practice with that method so that in the future you are prepared when you start to solve longer equations. So let's talk about this new method called isolating the variable. What does that method look like? Let's jump into the first example problem and kind of get a visual picture of what isolating the variable will look like. In this problem here, we're solving the equation x plus 6 equals 9. Remember, we're learning a new method called isolating the variable. This picture here shows what the equation currently looks like on a balance scale. We have x plus 6 on one side, and we have 9 on the other side. In the substitution method, we would just try different numbers in for the x and see what works. In the isolating the variable method, it's a little bit different. When I'm saying isolating the variable, I'm using the word isolate. Does anyone know what the word isolate means? Go ahead and pause the video, Google the word isolate, see what definitions you come up with. Did anyone find a definition that said to put something by itself? Something is alone when it's isolated. If we are isolating the variable, what's the thing that we're trying to make be by itself? What's the thing that we're trying to get alone? If we're isolating the variable, we want the variable to be isolated. Remember, a variable is any letter or symbol that takes the place of a number. So x, y, z, those are all variables. So if we are isolating the variable, it means that in this picture here, we want there to be an x on one side of the balance beam, and we want there to be numbers on the other side of the balance beam. Well, we do have an x on that side of the balance beam, so that's good, but we also have 6 other blocks that represent positive 6. We need to find a way to remove those blocks without disturbing the balance beam. If we just start taking these blocks off, what's going to happen to the balance beam? It's going to get tilted. This side over here is going to be heavier, so it's going to fall down. The other side's going to be a little bit lighter. So we can't just start taking the blocks off because we need everything to stay balanced and to stay equal. But remember, we still want to isolate the variable. We still want there to be an x on this side, and we want to get rid of all the other blocks. So how can we do that with keeping the balance beam equal? In order to isolate the variable and keep the balance beam equal, every time we take a block off of the left side, we also have to take a block off of the right side. So if I'm taking off 2 blocks there, I'm going to take off 2 blocks over here. Then I'm going to take off another block here and another block here. As long as you take off the blocks at the same time, the scale's not going to move at all. Let's keep going. I'm going to take off this block here and this one here. And then I'm going to take off one more and one more. All right, now I have removed all 6 of the blocks that used to be on the left, and so I have successfully isolated the variable. On my new balance beam, I have an x on the left, and what do I have left over on the right? I have 3 squares, which represents the number positive 3. So this picture is showing me that x is equal to 3. Let me show you a simplified picture. In this picture here, it clearly shows that x is equal to 3. Now, if you don't want to draw a balance beam every time you use this method of isolating the variable, let me show you the algebraic way to show your work and to write things down instead of drawing the picture. The original problem that we had was x plus 6 equals 9. I'm going to write that original problem over here, x plus 6 equals 9. To isolate the variable, I'm trying to get x by itself. I need to get rid of this plus 6. How did we get rid of the plus 6 in the picture? Well, we took them away. We subtracted them. So I'm going to, underneath this, I'm going to write down minus 6 because that's what we did. We subtracted the 6. But what did we do on the other side of the balance beam? We also had to take away 6 to keep it equal. So I took away 6 from the left, and I took away 6 from the right. I took away 6 on both sides, and that kept my equation equal and balanced. On the left side, I ended up with an x. The positive 6 and the negative 6, they cancel each other out. Because if you have positive 6 something, and then if you have negative 6 of something, it's just going to equal 0. So on the left, we have isolated the variable x equals, and then on the right side, we're doing 9 minus 6, which equals 3. So this method here is a method that you can use to algebraically show your work instead of drawing out a graph for every single problem that we work on. Now I know that this method seems pretty basic and pretty easy now because of the types of problems that we're doing, but remember, eventually you're going to be solving problems that are much more complex, so it's very, very important that you build the proper technique and the proper skill right now in isolating the variable because it's really going to help you later on. Let's do one more example problem like this. In this problem here, we have 6 is equal to x minus 3. So this is showing that we used to have an x on the right side, but 3 has been taken away from it. So in order to isolate the variable in this problem here, we have to add 3 more back onto the right side in order to get our x back, because right now our x is missing 3. So using the algebraic method that we learned in the other problem, I'm going to take my equation of 6 equals x minus 3, and I'm going to add 3 to both sides here. When I add 3 up here, I'm going to fill in this, and I'm going to fill in this, and I'm going to fill in this. And now that I've added 3, now I just have x. So this bar represents x. And when I add 3 over here to this side, to keep everything balanced, now I have 9. So I have 9 is equal to x. It doesn't matter which way you write it. You can leave it like that, or you can say x is equal to 9. So the answer is either 9 equals x or x equals 9. It's very important when we work on these types of problems that you get into the good habit of showing your work, and this is how you show your work. You show your work by writing down the step that you're doing to both sides. In this case, I wrote down +3 and +3, and that was my way to show my work. All right, I have a few problems for you guys to try on your own. Here they are. Go ahead and pause the video and give these 5 problems here a try. Make sure to show your work for each step. All right, here are the answers. Go ahead and check your work, see if you got the same answers that I did. But remember, the answers are actually not the most important part of this. The most important part of this is making sure that you understand how to isolate the variable using the method that we're using in this video. The first one, they kind of show you how to do that. Let me walk you through number 2, 3, 4, and 5. For number 2, we have f plus 5 equals 14. To isolate the variable is f. That means I have to get rid of the plus 5, so I'm going to do the opposite thing to both sides. I'm going to subtract 5 and subtract 5. These will cancel, and I'll be left with f is equal to 9. For number 3, we have 26 is equal to g plus 11. To isolate this variable, I have to get rid of the positive 11 by subtracting 11 on both sides. 26 minus 11 is 15, so 15 is equal to g. Number 4, we have w minus 6 equals 10. To isolate this variable, I have to add 6 to both sides. Then these will cancel, and I will get w equals 16. And for number 5, we want to isolate the z by adding 9 to both sides. Then we will find that z is equal to 30. All right, great job with these problems. I have a few more problems for you guys to try. But the next couple problems that you do are actually not going to technically be a part of this video. This video is technically going to be over right now, so you can take a picture of your notes that you did and you can submit those to Canvas right now. The next few problems, if you're going to try some more, are just extra practice problems if you're done. If we still have some class time left, these are just some extra practice problems for you guys to try. So right now you can actually pause. You can take pictures of all the notes that you took today in this video. You can submit your notes to Canvas, and then you can try these last few practice problems here. The practice problems that we're going to finish with are on page 65 of your book, and we're just doing the addition and subtraction problems today. Later, we're going to do a different video on multiplication and division. Please do not do the multiplication and division problems yet. I know that you can do them using the substitution method. I do not want you to do them using the substitution method. We are going to learn the isolating the variable method for multiplication and division. I want you to wait until you learn that method and then try the multiplication and division problems. For today, we're only doing the addition and subtraction. Again, these are just extra practice. You don't have to turn these extra practice problems in. If you're working on them right now during class time, you can ask Miss Mercer on Microsoft Teams to check your work for you, to check your answers for you, to give you help with any of the problems that you would like extra help with. So these are just extra. You can work on these and you can chat with Miss Mercer on Microsoft Teams as you're working. Thanks guys, that's it for today. Have a good rest of your day. Bye.